So this is part 2 of our work with dictionaries, and we're going to look at the way dictionaries are used in counting things. So this is a pattern that Severance really explained fairly well, and I'm going to demonstrate it with the string Mississippi. And the objective of this code is to count the number of occurrences of every letter in the spelling of Mississippi. And you start by initializing an empty dictionary, count dict. And when we get through, the objective is that in this dictionary, every key is going to be one of the letters that occur in Mississippi, and the value of that key will be the number of times that that letter appears in Mississippi. And you can do this by hand. How many times does S appear? Well, there are 2 S's here, 2 S's here. It sounds like 4 to me, okay? So here's the way we do it. So for C and S, that is, you iterate through the string Mississippi, take every element in Mississippi, and ask, well, is this letter already in count underscore dict as a key? If it is, then you add 1 to the current count of times that that letter occurred. If it's not already in the count dict, then you have to start that key value with 1. Okay? And if you didn't do this, if you tried to access count under dict of C when it doesn't exist, then your program would blow up. You'd get one of those traceback errors. And now we look at the results for K in count of dict.keys. That is, K is one of the keys, that is, some letter that occurred in the spelling of Mississippi. You print that letter and the number of times that that letter occurred in the spelling of Mississippi. And you see that capital M appeared once, I appeared 4 times, S appeared 4 times, and P appeared 2 times. Okay. So that's kind of awkward code, and because it's had to be repeated so much, there's a method which we use with dictionaries which won't blow up when you try to get something that's not there. It's the get method, and what get does, what count underscore dict.get of C comma 0, that says try to get the value associated with the key C, and if it's not there, return 0. Okay, and then add 1 to it. And that simplified code produces exactly the same thing that we got out of the first example code. Okay? So, exercise, use the simplified version of the counting code above to count the digits in the number blah, 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 blah. You can use the str function to create a string because you can't get through digits in an integer. Well, it would be very awkward to do that, but it's very easy if you just use the string function to convert this thing to a string. Okay, so we come to one of those points where you have to stop the video, do your work, and come back when you're done. Okay, you're back, so I assume you did your work. So we just took that code and looked at this sequence of digits as a string, made it into a string called S, and then there's the standard code just exactly like what we had when we looked at the letters in Mississippi. And then we count, let's look at the results, and we see that the 2 occurred 5 times, 7 occurred 3 times, 1 occurred 6 times. Looks like that's the winner. That's the most common thing. And the least common number in this particular number was 9. And this number didn't come from any place particular. I just pulled it out of thin air, so it's a result of my neuronal activity. Okay. So a little exercise, modify the code in the previous exercise so that in each line of the output, the count of occurrences of a digit is followed by the proportion of times the digit occurs. So again, this is one of those places where you have to stop the video and do your work, and then after you've tried that, come on back and take a look at my solution. Okay, you're back. So the only difference here is in the print statement, and we print K and then the count, and then the count divided by the length of the string. And you see that the one which occurred 6 times, that was 21% of the letters in the string. Or not letters, but number characters in the string. Okay, let's go do something else. So let's apply the code to calculate counts and relative frequencies of occurrences in a list rather than a string. To create a list without a lot of typing, we start with a string and use list to convert the string S to a list L. This is just a proof of generality. So use the string. This is just a proof of generality. Okay, that's your string. So again, this is an exercise. So stop the video, do your work, come back, and we'll talk about it. Okay, you're back. I assume you've done your work. And what we did, we took the string S, and instead of playing with the string S, we converted it to a list called L, and in this font, L looks exactly like a 1. And then this is the standard code for counting things. And we get in this string the blank space occurred 6 times. It was the most common thing that occurred. Okay? We could have done that as a string, but we did it as a list. No real difference. The syntax is almost identical. Okay? So sometimes we want to know which value occurs most frequently. In the previous example, the blank space was the most common character. It is always possible that there is a tie. In an extreme case, all values could occur with an equal frequency. This is just to say that the answer may be a list rather than a single value. The following code solves this problem. So again, we repeat what we did before. S is Mississippi. And we get the count dict, which will be what we saw at the very beginning of this presentation, and we're familiar with that. And now we ask, what's the maximum count? Well, obviously looking at it by hand, you can see that there are 2 things, I and S both tied for the maximum count and at 4. And here's the way we determine which letters achieved that maximum count. So we create max count is the max of count under dict.values. So that's obvious. Max count will be 4. And now we're going to get a list of the winners. So the way we create the list of winners is, of course, whenever you create a list, what you're going to do is start with an empty list, and then you iterate through the keys in count dict. And if the value associated with that key is greater than or equal to max count, then winList.append I, that is, you add that I to the win list. Okay? Actually, this could have been equal instead of greater than or equal. You're not going to be greater than the max count, so really the greater than or equal, yeah, that'll work, but it probably should have been equal. And the most frequent times, you see that the win list consisted of both I and S. Okay, let's go do something else. Create a list, num list of the numbers between I and 100, S strings. So print the list to verify correctness. That is, we have a list of strings, and each of those strings is a could be an integer someplace between 1 and 100, but we're thinking of it as a string rather than an integer. And I ask you to print it out. So again, this is an exercise, so stop the tape, or stop the video. It's not a tape. I call it a tape, but it's really a video. And after you're done with your work, come on back and take a look at my solution. Okay, you're back. You must have done your work. Let's look at my solution. So num list is the empty list, and then for I in range of 1, 101, so this will start at 1. The first thing in the list will be 1. And the last thing in the list, of course, with the range command, it's 1 before 101. So this ends the list with 100. And then I convert that value of I, to which is an integer, to S, which is a string, and I append the string to the list. And you can see here's where it started off, and it runs off the end of the page here, but if you do this in CoCalc, you will see that the last, it'll be more obvious that the last number in the list is 100. Okay? On to something else. Drop the print from the previous character. Extend the code to create a list, FD list, of the first digit in each item in num list, and print this list to verify correctness. So the list that you create, in addition to the original list of numbers, you're going to create a parallel list which has the first digit of each number. So for instance, if the number is 25, the first digit is 2. If the number is 10, the first digit is 1. Okay, that's what I mean by the first digit list. So let's take, well, okay, stop the video, do your work, and come back. Okay, you're back. I assume you've done your work. So here's the modification. In addition to num list, we start off with an empty list, FD list, first digit list. So in addition to this, putting the value of the integer itself into num list with the append, we also extract the first digit of the number and put it in first digit list. And then we print first digit list, and let's look at what happened. Here's where we got to 10, and instead of 1, 0, what we find is just the first digit. Then there's 11, then there's 12, then there's 13. Okay? So on to the next question. Drop the print from the previous exercise. Extend the code to get counts and relative frequencies of the items in FD list. Okay, this is an exercise, so stop the video, do your work, come back when you're done. So here's what we had before, this code right here, and now we've extended it. We're going to get a count of the things in count dictionary of the first things, the first digits. So for C and FD list, count of dict C is count of dict.get of C comma 0 plus 1. Very standard code. What you will have in this count underscore dict the keys will be first digits, and the values will be the number of times that first digit occurred. Okay, so this is kind of what you'd expect. 1, 2, 3, all the first digits, 9, 0 never occurs as the first digit because we don't print a leading 0. And they occurred pretty much the same fraction of the time. Okay. So change the 100 in the previous answer to 200. Rerun the code. Very easy exercise, but stop the video and do it and come back and we'll talk about the result because there's something kind of interesting there. Okay, you're back, so I assume that you have done your work. And the only thing that's changed in the code is that we've got the list ends at 200 rather than 100. And now what do we find? Well, this is kind of interesting, and you can understand why it happened. The 1 as a first digit now occurs about 56% of the time. Well, why does that happen? Well, once you get past 100, all of the first digits are 1 all the way till you get to 200. Okay? After you got to 200, you start to see more. If you went up to 300, you would see also that you had a whole lot of first digits of 2. Okay, so this is what you get. The 1 occurred predominantly. So the last exercise is a research question. Google for Benford's law. What do you find? This Google reading should be very interesting. You'll find that the main result is that in naturally occurring numbers, the digit 1 will tend to occur more frequently than the other numbers. And the reason for that, you kind of saw when we got beyond 100 and we got all the way up to 200, 1 naturally occurred about half of the time. Now, look at what happens when you're somewhere between 1,000 and 2,000. If you went all the way up from nothing to 2,000, again, you'd have predominantly 1s. Okay, now get up to 10,000. When you get to 10,000, you'd find that all the first digits are basically equivalent, but between 10,000 and 20,000, you would find predominantly 1s. Okay, go all the way up to 100,000, and now between 100,000 and 200,000, again, you get predominantly 1s as first digits. And this sort of gives you a very casual, probably not truly compelling explanation for why Benford's law works and why forensic accountants can look at numbers which violate Benford's law and say, it looks like somebody faked something. Very interesting topic. Okay, so that's the end of today's lecture.